The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. InsideAnalysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanaugh.
All right, folks, welcome to the future indeed. It's coming towards us at full speed, breakneck speed. Yours truly, Eric Kavanaugh, here on the only coast-to-coast radio show all about the information economy, Inside Analysis. And today we're going to talk about one of my favorite topics, folks, open source technology, open source software, in particular Apache Kafka we'll talk about, but some other things are going on too. There's some end of life, as some of you may know, with CentOS, which is an operating system that's been relied upon by thousands and thousands of companies. That happened at the end of this past year. So a lot of companies are still slugging it out, hoping for the best, working with companies like our guest today works for, Javier Perez from Perforce, and that's what they're doing. But there are lots of other things happening, and we really need to keep our eye on the ball here, because not living up to the latest standards and patches and so forth makes you vulnerable to all kinds of bad actors. And of course, there are lots of those out there, and it's not changing anytime soon. There's ransomware. There are other things, protestware I heard about before the show. So we'll talk about that a little bit. But let's bring in our guest, Javier Perez, open source evangelist for OpenLogic by Perforce. Welcome back to the show, Javier. Tell us what's the latest on my favorite, of course, Apache Kafka, which of course came out of LinkedIn. Some cool use cases happening there. What's your take on the latest in the industry and where things are going?
Hey, Eric, great to be here again with you. Always fun to have a good chat about open source and technology. Well, Kafka, for some of you that in the audience that are not familiar with Kafka has really become the new middleware. That's my own term. Don't quote me on that. But there used to be a lot of well classified as middleware technologies, right? Helping being between the applications, sort of the front ends, and the systems of record, the databases, where the data goes and comes and goes, right? And you needed a middleware technology to help you with that, and it was very specific to the programming language, right? So you had middleware for Java applications, for .NET applications, for JavaScript and Node.js applications. With Kafka, we are looking at the different technologies. And by the way, I don't like to call them databases anymore. Yeah. I like to call them data technologies, right? Because
interesting.
What's a database nowadays, right? They do a lot of other functionality, and it used to be, just one or two relational databases. Well, they're still around, but now we have so many different options, especially all of them coming, or most of them coming from open source.
That's right.
Apache Kafka happens to be really specific, very specialized on streaming large volumes of data. And that's when I was saying that, kind of the new type of middleware, because that it provides those functions and more, right? As we see, there's even more and more data, right? Social media, Internet of Things, just everything is digital now, right? So everything is accumulating data, accumulating log files, accumulating system records. If you can transfer that data quickly to a data lake, a database somewhere else, you are in a better position to help your customers. And that's what Apache Kafka is. It's new technology. You mentioned LinkedIn. That like many of these popular open source projects, they start as an internal project.
That's right.
Companies that are that have an open source strategy, that see the benefits of putting it out there, so they can get more contributions, so they can get more people improving their software. And that's what they did. Actually, it was just about 10 years ago. I believe it was 2011. So basically in 11 years, we have now a robust and stable technology that is used by thousands and thousands of applications to stream data. And then what do you do with that data? You can do so many different things, right? I mean, you can integrate from multiple sources. You can send to multiple sources. You can send it to generate some analytics, some statistics, some charts. You can do so many different things with this technology, and by the way, integrates with many of the other open source data technologies.
Yeah, and let's give some examples to the audience, because just for example, like to think of in a marketing or a sales context, you'll want to know what people are saying about your products in reviews, for example. So you could set up a topic, is what they call them in Kafka, that is a feed of any review that's coming through from any system. And you can point that at multiple targets. I think that's the key, right? So typically you would persist all your customer data in one database, and then you'd have the applications pinging that database to get information. With Kafka, you have a significantly different architecture where it's pushing out streams of data, and you can subscribe to them or not. So it's like a classic pub/sub type system where you're publishing the streams, and then various clients can receive the stream. You have to find some way to point the fire hose, I guess, when it arrives. But that's the idea, is that you can take one stream and publish it, and any number of clients can grab that relatively real-time data that's streaming off of whatever system you want, right?
Yeah, I mean, this events or transactions these topics that you mentioned, those are really events or transactions, right?
Mm-hmm.
With Kafka, it's called topics. And then you can make use of Kafka Connect, which is like the other layer with all those integrations, all those APIs to integrate connectors, to integrate with all these different either source data sources or destination data sources. So there are plenty of connectors, part of this Kafka Connect out there. Many of them completely open, public, free. Some of them are proprietary by some of the companies that commercialize Kafka, and there's the ecosystem has grown so much, and that's a lot easier. That if you want to integrate with data in data lake in AWS or in Microsoft Azure or Google Cloud, well, most likely there's already a connector, Kafka Connect connector for you, and you just consume that connector, right? And that's the other piece, right? In open source and technology in general, the larger your ecosystem, the better, right? You get more users, easier for them to use, and then you just keep growing that ecosystem.
Yeah, and I think a lot about the use cases. It's my sense from the research that we've done and talking to folks like you that most of the use cases for Kafka in particular are really net new systems being built by organizations. So they see the possibility of what they could do. In other words, it's not so much replacing old systems, but I think that might be coming down the pike sometime soon. That said, I've always found that sunsetting an application is probably the hardest thing to do in the universe. I think I may have told you my favorite quote from this guy, Gilbert Van Cutsem, once joked that he said, "Elephants go to a special place to die, but there is no software graveyard. It all just goes to the cloud." I just find that so amusing. It is hard to sunset systems, right?
Especially if they're mission critical kind of production systems. Absolutely, right? And we'll talk about some of the other technologies, which makes the point, right? Things like Angular and CentOS. But yeah, so with Kafka, I agree. We've seen many of the new applications just being implemented with Kafka. We see use of other data technologies like Apache Hadoop or Cassandra or Spark that are integrated with Kafka. So Kafka is the one streaming the data, and then the data it's being handled or storage with those other technologies, open source data technologies, by the way. The growth of AI and machine learning applications has helped also the growth of Apache Kafka, Apache Spark, right? Because again, when we're talking about AI and machine learning, we're talking about very large volumes of data, right? Just think on, let's say, Alexa, Echo, AWS, right? How much data it's receiving and transmitting, right? right? So you ask a question to Alexa, and the data goes and grabs that information from somewhere, right? That's streaming data. This is streaming data and huge volumes of data, and that's up. And then you use all of that to train your machine learning models to make predictions for the next time that question is asked. And this is just a kind of a high-level simplified example. But the point is, with the growth of AI and machine learning applications, we've seen a growth of streaming data with Apache Kafka, and then storing with some of the other technologies and having the data on data lakes.
That's interesting, because you figure, I'm pretty sure Siri and Bixby on the Samsung devices, they are trying to understand, in your instance, they're trying to understand you and how you talk. I mean, this goes back to the earliest models. Remember, what was it, the Apple, they had the, what was it called? A device where you could do handwriting and they could translate it. This is like in the late 1980s. It was the first version
Newton.
of something.
Was it Newton?
Newton, that's right. It was, wasn't it Apple, the Newton? That's exactly right. And the idea was it would learn. So it's the same principles being applied. It's just that today we have much more compute power to leverage. We have much more experience in building the models. And what's really cool about all this, and I think this speaks to the power of open source, is that you now have this massive marshaling area called the cloud, and a massive group of people marshaling the technology. Those are the open source committers and everyone who's involved in these projects. And really, you have this rising tide lifting all boats, because like you look at NLP in particular, and the work that's been done by Google and some of the other major players is absolutely fantastic these days. I mean, these engines have gotten so much better than they were 10 years ago, because again, we're training the models and retraining them, and we're learning how to do this stuff. And so it's quite exciting. And I think, again, the open source movement has a lot to do with having got us here. And even though there are some painful things we could talk about, like the end of life for CentOS and the end of life for Angular, I mean, these are straws in the wind for having to dot your I's and cross your T's. But nonetheless, it's amazing the power that has been unleashed in just the recent few years, right?
Yeah, I know, unbelievable. I mean, you just reminded me not only the Newtons, but the Palm Pilots with the stylus, right?
Right. Yeah.
Well, we're aging ourselves. We've been around for a long time.
I know. Sorry to do that to you.
No, it's fascinating. These new technologies, and let me just for some that maybe some in the audience that are thinking, AI, machine learning it's gonna go nowhere. It's gonna be the demise of the humanity.
Right.
We're far, far, far away, right? Just to get that out of the way. We are hundreds and maybe 100 years or even more to get some level of intelligence that is superior to human intelligence. But what we do have is be able to process millions of transactions with huge volumes of data. And for that, we can use machine learning and deep learning models to train to make sure that we know the answer next time it's asked. We can talk about like image recognition, which, by the way, that also has to be streamed. Much larger volumes of data that have to be streamed. Or we can talk about audio or voice recognition, or we can talk about just text, right? Or speech to text. And there's so many things to talk about this. And it's been around for some time, but now, as you mentioned, now we have the cloud and we have much more capacity in those microprocessors, so we can handle a lot more data, right? We can do a lot more with graphics. The bottom line is some of the building blocks not only are open source software, but the building blocks are some of the same principles that we've been talking about for many years, for 20, 30 years, right? It's about getting the data, processing the data. But by the way, Kafka can do that too. Reformat the data and send it somewhere else, right? Or get the data from multiple sources, process that, generate it in a new format somewhere else. Some might argue, if some of the listeners are experts on Kafka, they'll say, well, don't waste Kafka doing processor and post processing. Use it for transferring. If you want to do some processing, do it before Kafka or after Kafka. Use it for streaming. But you can still do some of that processing with a technology like Kafka or with many other technologies. So the principles are still the same in terms of, we have now much more data. we have the capacity to do that. Why not use those AI and machine learning, deep learning technologies to help us with that?
Yeah, I mean, I feel like organizations really need to have pretty clear roadmaps these days, and you have to understand first of all what is your existing landscape. What are the applications you have that are mission critical? How are they running? How can we bring in open source technologies to sort of augment what we're doing, as opposed again to replacing what we're doing? I mean, I do think that we're going to see, and we are seeing, redesign of systems as we deploy into the cloud. That said, there are companies that still lift and shift. That still happens. It's not really the most, I think, wise way to go, to just take your on-prem environment and shift it up into the cloud. It's not a very strategic move, it doesn't seem to me. But point being, you really do need to have a pretty robust understanding of your own information architecture, where the dependencies are, and then allow yourself to be able to see, all right, well, how can we kind of prepare ourselves for the next phase, which I think is going to be heavily based in the cloud, right? But there's so many little interdependencies and connections that you have to nail down. And yes, we can all use APIs these days, but there are issues dealing with APIs as well. So, I mean, do you find that there is a greater appreciation for information architecture as we move to the cloud?
Well, yeah. I mean, and there's more stuff coming up, right? Like serverless,
Right.
function as a service technologies, and well, just the whole cloud native, right? The whole use of containers. Once again, we need to get all those open source now to work natively on containers and Kubernetes environments, right? Which, by the way, Kafka also can do that really, really well. So when you're looking at open source technologies or any technology now, as you build new stuff, maybe not maybe to move away from some maybe legacy technology, is to see if it runs natively in, for example, a Kubernetes environment, right? That's what it's called, a Kubernetes operators. Kafka is another example of a good way to kind of natively be installed and easily work within containers and do exactly the same functionality that it does without the containers. So that's another area. And yes, architecture is key on all of this. There are plenty of jobs out there for good architects, for sure.
and there probably will be for quite some time, folks. And there are cloud architects. We've done a couple shows on that. There's a lot happening in the space of cloud architecture and building out your environment to optimize what your business does, because every business is different. Well, don't touch that dial, folks. We'll be right back. You are listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
Take this to the future.
All right, folks, back here on Inside Analysis, talking all things open source with Javier Perez of OpenLogic by Perforce. We're talking about Apache Kafka, which really is game-changing technology. And there are lots and lots of use cases for Apache for streaming. But really, it's an architectural change. And I remember interviewing Jay Krebs from Confluent, one of the three founders of, I think there are three, for Confluent years ago, about the direction that they were going. And I likened Kafka almost like to the interstate highway system built on top of and around all of our local highways here in the US of A, because you still have your local roads you can take if you want to get there, or you can get up on the highway and get someplace faster, basically, is kind of how I view with the cars being the packets, basically, of information flying around, right, going place to place. But it is sort of a superstructure, and I think it is probably the future. Now, in the last segment there, you just referred to cloud native, which is a very interesting topic. And of course, there's DBT. I'm guessing you've come across those folks as sort of the T in Transform. And they have an interesting play on cloud native that I've seen because of how they design the transformations. And they design them in a way such that it can publish out to whatever system you want. So you design your transformation and the target is X, Y, Z, or whatever. The point being, you don't have to change everything and then recompile if you move to a different cloud environment. So that's a pretty interesting and very pragmatic take on cloud native. But what's your thought on what it really means to be cloud native these days? How can you design with cloud native in mind and know that you're at least kind of greasing the tracks to the future of enterprise computing?
Yeah, no, thanks for the question, because it's important to clarify, and I think there's a little bit of misconception because you hear from different vendors, and we get a little bit of when we started with cloud and cloud offerings, everyone claimed to be cloud, in the cloud, right? And we used to call it cloud washing. Everyone talks about cloud. They don't even know about cloud, but they talk about cloud. Well, it seems to be a little bit similar, some similarities with cloud native. Just to simplify it, if your workloads, meaning your applications, your applications are container-based, that means that you are using technologies that are being built for containers and for the operation of containers. That's what we're referring to cloud native. Now, doesn't have to be in a public cloud. Can be in a private cloud, can be in your own dedicated cloud, could be on-premise, but on-premise on a cloud environment on-premise, right? Or virtualized environment or containerized environment in your own server or locally in your laptop on your MacBook. So when we talk about cloud native, it's that. Now, that's the area of largest growth across all open source, right? We have, first of all, container standard, right? A lot of people talk about Docker. Docker is one. Podman gaining a lot more popularity, actually, but it's using the same container standard. So you can use either way, or that's not an issue. And then as you grow with your use, with your deployments, you need a way to manage not one or two containers, but to manage 50, 100, hundreds of containers. And that layer is what it's called orchestration, right? Or management or an orchestration of those containers. And that's when we refer to Kubernetes. Kubernetes basically is the leader in that space. There are a couple of others, but Kubernetes is the leader. And now they are commercial versions of that kind of container platform orchestration with using Kubernetes. Yep. Kubernetes is one of the most successful open source projects ever. We have hundreds, thousands of commits. We have many every day. And we have the largest organizations, all part of the Cloud Native Computing Foundation, basically sponsoring that foundation so they can move forward with everything that relates to containers and Kubernetes, which is all the Cloud Native ecosystem. If you take a look at what's going on Cloud Native Computing Foundation, there are so many projects out there, right? And there's more. Not everything makes it to the foundation.
Well, so that's a good point. You got the Apache Software Foundation, you've got the CNCF, Cloud Native Computing Foundation, you got the Linux Foundation. So you have a bunch of these organizations, but they are still at least loosely collaborating, if not very tightly collaborating on these different projects. And so again, you see open source fundamentally changing how software is designed. I mean, this whole concept of product-led growth, for example, it's very much an open source movement. You've got MinIO, for example, out there, which is like what S3 for everybody else is what they call themselves. It's kind of a remarkable to see all these different projects. And I guess that's really the benefit of a company like Perforce, because you folks are keeping tabs on all this. And so you are aware of which releases are coming out, what the changes are going to be, where that's going to impact. And to our point earlier, a lot of it is around vulnerabilities of hackers and of bad things happening. So, you guys do some patches, but not many. I mean, really, at a certain point, companies have to make the hard decision to kind of bite the bullet and go a different direction, right?
Yeah, no, and thanks for mentioning that. OpenLogic by Perforce, we cover a very specific niche, which is that expertise on open source software. We provide the support to our customers there. And that touches in another interesting point, right? When you see, for example, all those cloud native projects, but all open source, Kafka and many others, that they are becoming really successful, very popular projects, you have more contributions, which means the software keeps improving, right? And you are issuing releases. And if there's a bug, someone goes and fix that bug, and now you put the fix on the next release. Could be a minor release, could be a major release. If you find a vulnerability, you disclose the vulnerability and you provide the fix, that also goes on the next release, right? Or the next patch if needed, right? Depending on the severity of the vulnerabilities. So today, open source is working really, really well like that. I mean, it's obviously not perfect, and there's many initiatives around part of the Linux Foundation, by the way, the Open Source Security Foundation, a lot of initiatives around kind of addressing some of the concerns and the fact that, we're talking about thousands and thousands, probably millions of open source libraries that, are they secure? Are they safe? Are we disclosing vulnerabilities? All those things. So the expertise on the projects, the expertise on telling you, well, I can just update if an IT, someone from operations is listening, is going to say, well, just because there's a new release or a new patch, I'm not going to update my production application, right? I need to schedule that. I don't want to move there. Right? You need to tell me what exactly is changing, what's going to affect my that, and that level of expertise is what we offer. But it's a reality. It just keeps moving. Last time we spoke, Eric, we talked about like the state of open source report,
right.
that major survey. Just reminded me because the top three or one of the top three open source support challenges for organizations is to keep up with updates and patches.
Yeah.
That's one of the top three. Another one is, of course, the proficiency and expertise by your own team, right? Mm-hmm. So those are the challenges that we see in organizations today. But at the same time, going back to the foundations, that's where open source is happening, right? There's no doubt that without the sponsorship and the support of many organizations, open source wouldn't be where it is today, right? So yes, it's all cool to have someone open sourcing their own code, individual contributor, and then other people use it. That still happens, but some of those popular, most used open source software, it's because it's been really created with many sources, with many organizations sponsoring, supporting those efforts.
Yeah, and you talked too about the end of life. We've talked before on a different show about the end of life for CentOS, which was made a lot of people unhappy. There's also an end of life that happened at the same time of Angular, which of course is one of the big platforms for front end design, right? If you got React, you have Angular. I think those are the two biggest, and then lots of other small players out there. But the front end of applications is a pretty important part. That's the UI, it's the interface, it's how you interact with things. So that was a pretty serious deal. And, well, how much activity do you guys see on that front?
Yeah, no. And by the way, I'll before I forget, I'll mention also my PHP is also popular on web applications, and our friends from Perforce also we are very good at the PHP with the PHP community. No, I mean this is a major thing. So let me just step back for really quick to explain. Angular has been around for a long time, 11, 12 years. AngularJS, it's version 1 of Angular. It was around for about 5 years, 4 to 6 years to be exact, to get basically anyway, was around for so many years. And the Angular community decided to build it again, like rewrite Angular. And they did it because at that time, around 2011, 2015, that was a major change in applications, which was going from web applications to mobile applications, right? So applications that you go to the browser and use versus, now I have everything on my phone. And they built this Angular version 2. They rewrote it. They use a language called TypeScript, not JavaScript, but TypeScript to build the Angular version 2. And they address that, make it flexible to be able to write application or mobile applications, right? Java using JavaScript, but building mobile applications. And then from there, they went to version 3, version 4, and so on, right? I lost count. I believe we're in version 13 or 15 now. The problem with that is that AngularJS was built on JavaScript. It was a rewrite for version 2. Right. So what that meant is that if you wrote your application using AngularJS framework, you can just upgrade to the next Angular. You actually, basically, that means a rewrite of your app.
Ouch.
And that's why, the community, Google was a big part of that, but the community, the open source community, decided, well, let's keep supporting it, right? And when we said supporting it, it's maybe not necessarily that many improvements, but just keeping up with some of the fixes, bug fixing, and vulnerabilities. And they kept it for 11 years until, I guess, enough was enough.
Wow.
And it became end of life on December 31st, 2021, which means the community no longer produces any patches, any updates, nothing. Right. So there are still a good few thousands, if not many thousands, of applications out there that were built with AngularJS. Some of them might not be all that old, maybe just recently, but the developers had experience with AngularJS and decided to use AngularJS, just like that. So there are options now, and yes, definitely it's a rewrite of the app. But if you stay with it, who knows when the next major critical high severity vulnerability is going to pop up, right? And now you're not going to have to fix the how to address that. So option is, well, you take the risk, or you go and rewrite your app using the latest version of Angular, or you rewrite your app just going to another framework. Could be React. You mentioned React, or others. Or the other option is, let's get support. Let's get someone that might help you with the patches while we work on the new app, or maybe we just decommission the app, right? so to get some peace of mind in terms of hopefully someone that will address any critical patches. That's some of the work that we do at OpenLogic by Perforce. But very similar situation with CentOS. End of life is that's it, right? In the case of CentOS, you have to migrate to another Linux installation and then test again everything, making sure that everything runs properly again, and make the necessary changes if needed.
Yeah, that's just got to be an absolute nightmare, which is why you saw so much anger over that decision. But what are you going to do? I mean, we had a guy on the show too from Command Prompt who was joking, "Hey guys, it's free. How much more free stuff did you think you were going to get?" So you do have to be very practical about these things. But the shifting sands, it reminds me of the old days of the Microsoft operating systems, when you had so many different OSs and all these different application vendors who would cater to the Microsoft world would then, I'm pretty sure, have to go back in and look at the new release and figure out, okay, how are we going to make the changes necessary for this one? And my theory, and we got about a minute before the next break here, is that that was one of the reasons why Linux became so popular, was because Microsoft kept pulling the rug out from underneath people with the operating system. And so then I think IBM saw the vision of investing $1 billion to harden Linux to make it an industry, industrial grade operating system. I think that was part of the reason why. Real quick, what do you think?
Yeah, very well. Could be that, and the fact that you were working with a black box, right? You couldn't do much quite on Linux. You can do so much on Linux. Those were the factors. I remember way back on my college day that those were the debates, right? Windows, Linux, and so on. But just briefly going back to the previous point, is all software has actually an end of life, right? There's always the point where you are going to have to deprecate that software. Could be APIs or any software, and we have to deal with it.
Yeah, that's it. You got to start planning now, folks. Well, don't touch that. I'll be right back with one segment more with my buddy Javier Perez from OpenLogic by Perforce. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
Okay, folks, welcome back to Inside Analysis. You're truly Eric Kavanaugh here with Javier Perez from OpenLogic by Perforce. And in the break, we were talking about a couple of things. Rocky Linux is one, but the other one that maybe we should get into instead is this whole concept of WebAssembly, WASM, as it's being called. There's a company, Single Store, used to be called MemSQL, and they gave me a briefing a few weeks ago and talking all about how they're really embracing this WebAssembly language, which is a sort of lower language, like assembly. You remember the different bits and bytes. I think assembly is right above that. And so this is kind of interesting. Tell me your thoughts on what WebAssembly means and why it's important.
Yeah, there's been a lot of talk about this and recently, and I heard multiple presentations, actually, one from the CEO of Sixthought about it. Yes, a much more simplified language. When you have a kind of simplified language, it helps with performance, helps with capacity. A lot of the embedded systems, a lot of the IoT software for IoT, it's developed on C and C++. And the reason is because of the low use of memory, low use of resources. So you still use C and C++. Probably a little bit more C++ now than C, but that's what you see on all these embedded systems. So WebAssembly initially was just more focused on a kind of browser, kind of dealing with the browsers. But why not using the same set of instructions, the same language, to do some of the work, right? And that's the point, right? Which is a much simplified set of instructions. You don't need that many resources, so that helps with performance. And you can go as far, or that's what I'm hearing, that people, you go and install on a server, right? That takes time to do your installation. You go and then we went and go and install on VMs, virtual machines, and you still have to spin up the virtual machines. It still takes a few seconds or maybe a couple of minutes to spin it up. And then we move to containers, and you say, well, now it's just seconds, but you still have to spin it up and down as you need to expand those containers. And what they're seeing with WebAssembly is that you can go even faster than the containers, right? You can immediately activate, deactivate, enable, disable using those lightweight instructions. So there's a lot of talk about that potentially could be it's the future, is the next big thing, because we want to optimize performance, right? Everything is going to have software. Everything, or most of stuff has software now. You know how much software is in a car now, and it's going to just continue to increase. So the better use of those technologies, in this case, basically a programming language that makes it easier, and you simplify your software. It could be. I mean, I really think that's very possible. We're not that far from that future.
Yeah, that's interesting. I mean, essentially, and for the layman out there to understand this, I think it's important to figure out or to explain what's changing here. And as I understand it correctly, WebAssembly is taking what is essentially, like, let's say, an application that's in the cloud, so a cloud native app, but then when they communicate to another system, they communicate in the language that system speaks. So you're doing this sort of translation, almost like compiling the instructions in the language that this environment speaks. And because you're doing it at that low level, that's why you get this performance increase. Is that about right?
I'm not an expert on the details. I can just definitely tell you that less number of instructions to do the same amount of work. That's definitely helpful, right? You're definitely looking for that.
Yeah, right. Like you're being much more specific and lean. And it's funny because we have this concept of code bloat. Remember the first time I heard about this, and a developer at a former company I work with just explained it to me. And he said basically as processors got faster, developers could be a little bit lazier. You could have fatter code, slower code. It didn't matter so much because you had these faster processors to crank it out. Well, what WebAssembly movement is doing, it seems to me, is kind of getting back to first principles around the leanness of the code and the instructions, and really understanding. And you made a good point about IoT. When you're dealing with IoT use cases where you have, let's say, hundreds of thousands of assets that you're managing or tracking with all sorts of different sensors that have different battery requirements and different chipset requirements and so forth, if you can optimize the flow of instruction to those environments, you can save on power, energy, you can improve the speed, you can do all these things, which in an IoT world you're going to want to have, right? Like connected cars, for example. So it's a very interesting wrinkle and just another different way of doing things. And I think maybe to your point, we're probably going to start seeing other vendors talk about it and reference it. WASM, if you see WASM, that's what they're talking about, WebAssembly markup language, I think is what it stands for. But it's another interesting wrinkle that is shaking out, I think, out of need, because you have these crushing environments. I mean, you think about some complex IoT use cases, and I mean, there's all sorts of things that are going to happen to slow down your performance and what you as the administrator can see and do, right, Javier?
Yeah, no, and it's IoT and embedded systems and then everything else, right? Like medical devices, how many medical devices, automobile industry, all of that. By the way, I have to remind everyone, WebAssembly is also open source. So, and as you see more, you're probably going to see more software around WebAssembly, connectors, integrations, similar to what we were talking about with Kafka, right? Your connectors, your topics, and your connectors. So that as it grows, it builds an ecosystem, and then you have more contributors, and that's how it works with successful projects, like the case of Kubernetes or Linux distributions.
Yeah, it's just fascinating. So I just did a quick Google here. What can WebAssembly be used for? And just says with WebAssembly, you can develop high-performance web applications using open web platform technologies in various languages. It makes it possible to create video, audio, graphics, 3D environments, multimedia games. I mean, it's another interesting approach that can be used to optimize the performance. And that's what you always want, right? I think that if you can credit Facebook and some of these other big giants with one thing, it is changing the expectations of the user for how fast things need to work. It's like, well, if Google can work that fast, if Facebook can work that fast, why can't my basic system here at my company? And that has led to a lot of pressure on IT to optimize and to modernize and to figure some things out, right?
And get that level of expertise. The previous webinar, we were a panel of 3 and asked us, what technologies or what programming languages you recommend for new developers to learn. And someone said JavaScript, Node.js. That's what is happening. I said Python, right? Most of the AI machine learning is using Python libraries, and then the next one is WebAssembly.
Mm-hmm.
Could be the next major skill. Yeah.
Yeah. Well, it's interesting because they are different languages, and I have to remind people and myself even sometimes that software is written in languages, just like we have English and French and Arabic and these other languages. These software languages have different strengths and weaknesses. You talked about Python. That's a higher level language. It's declarative, so it can work with these lower level languages to come up with ways to do things. It's not as efficient as like a Go. Like Google's Go language is very efficient. C+ is very efficient. These older ones are efficient. Java, not so much. Java is sort of object oriented, right, with classes and things. And
she just reminded me a couple of interesting facts. Kubernetes, it's all coded in Go.
Is it?
It started in Google at Google Code, and in other companies like Red Hat and others, they're just building everything around in Go.
Wow.
Just to call it Golang. Go. They prefer Go, actually. The community prefers Go. The other interesting fact about languages, I'm talking about small set of instructions. Linux, the Linux kernel, now is moving in the direction of using Rust. Rust is another programming language.
No kidding.
One of the issues with C and C++ is that it could create some misuse of memory. Most of the vulnerabilities around with C and C++ relates to vulnerabilities within the use of memory. If anyone that it's or has been a C or C++ developer, they remember those overflow errors and those overflow issues. You address that with Rust language. Actually, Linus Torvalds mentioned that he is about to merge some Rust code into the kernel.
No
and
kidding.
that's a trend. That's a trend that we see as part of the open source security foundation initiatives to move more to replace C and C++ code with Rust code. So that's an interesting fact.
How interesting. And yeah, that's fantastic stuff. And of course, we have all this rich history now with DevOps and data ops, and we're getting much more efficient about how we're deploying code and in these very hybrid environments. It's fascinating what the big companies are doing, just rolling out tiny little, like 1% of the servers, 1% of the nodes will be new. and then they watch and see what happens. But folks, always nice to talk to Javier Perez of Perforce. We'll talk to you next time. You've been listening to Inside Analysis.